Good morning, one and all. My name is V. Abhijit Kumar. I am studying in third semester. My roll number is 249518662, CSE AI and ML, Institute of Aeronautical Engineering. In this video of the complex engineering problem of the subject of data structures, the topic I am going to explain is hybrid sorting techniques using Java for big data applications. First of all, let's go through the contents. In the first place, I am going to introduce the topic of data structures and sorting. Next, we'll go through what is hybrid sorting technique. Next, I'll explain why hybrid sorting is useful for big data, and we'll go through common sorting algorithms review. And after that, I'm going to explain the concept of hybrid sorting. And after that, I'm going to explain about popular hybrid sorting algorithms. Next, we'll go through Java implementation approach. Next, I'll explain a pseudocode for hybrid sort and merge sort and insertion sort, the mix of these three sorting techniques. And after that, I'll explain an example Java code snippet. And after that, I'll explain these applications in big data. And next, we'll go through advantages and disadvantages of hybrid sorting. Next, we'll go through performance comparison. Next, we'll go through future enhancements. Next, finally, I'll conclude the topic and I'll give the references. First of all, let's go through the introduction to data structures and sorting. Data structures organize and manage data efficiently. Sorting arranges data in specific order before descending. Sorting is fundamental for searching, indexing, and analytics. Common algorithms for sorting: bubble sort, merge sort, quick sort, heap sort, insertion sort, etc. etc. Now let's go through what is hybrid sorting technique. Hybrid sorting combines two or more sorting algorithms. The aim is to achieve efficiency by leveraging the strengths of each algorithm. Example for this is timsort. Whether in Python or Java or whatever programming language, it is a combination of merge sort and insertion sort. The idea is to use simpler algorithms for small data and complex ones for large data. Now let's question why. Why do we use hybrid sorting for large data, for big data? Big data systems in general handle huge data sets where single algorithms fail. Hybrid sorting in general adapts dynamically to data type and size. This concept of hybrid sorting, it ensures faster processing, reduced latency, and optimized memory usage. It is ideal, it's very ideal for distributed systems like Hadoop or Spark. Now let's go through a review of common sorting algorithms. Quicksort, it is fast but unstable on some data. Merge sort, it is stable and predictable, it uses more memory. Heap sort, it is efficient and in place but unstable. Insertion sort, it is ideal for small data sets. In general, hybrid methods combine these sorting algorithms very strategically. Now let's go through the concept of hybrid sorting with an example. Generally, hybrid sorting combines decision making with sorting logic. If size of the array is lesser than 50, use insertion sort. Else, we use merge sort. This is a logic which we can apply as an example of hybrid sorting. An advantage we have for this is that it handles both small and large data optimally. It offers reduced complexity in a practical use. Now let's go through popular hybrid sorting algorithms. TimSort, as we discussed before, it is merge plus insertion sort used in Java and Python. Introsort, it's quick sort plus heap sort used commonly in C++. Dual pivot quicksort, it is Java's primitive default primitive sort. And hybrid merge quicksort, it combines merge stability with quick speed. Now let's go through Java implementation approach. There are 5 simplest steps. First step, input a large dataset. We can give a large dataset as an input, and after that partition data into smaller blocks, and after that we have to apply insertion sort on smaller blocks, and after that we can merge results using merge sort or quick sort, whatever sort. And finally the output we get is efficiently sorted dataset, just as we expect. Now let's go through a pseudocode for a hybrid sorting algorithm. A hybrid sorting algorithm where merge sort and insertion sort are combined together. First of all, the logic we apply. If the size of the array is lesser than 50, we should apply insertion sort. We are telling the system to apply insertion sort for the array. Else, the entire logic for merge sort, we are writing it over there. The mid is equal to the middle element's index is equal to the size of the array by 2. The left part of the array is equal to the hybrid sorted version of the array from the 0th element to the mid element, and the right part of the array, the total array, is the hybrid sorted version of the array from the mid element to the ending element. And finally we are telling the system to merge this left and right, hence the array we get is a sorted array. Let's go through an example Java code snippet. First of all, we are creating a method hybrid sort. The arguments, the entities we are making it apart is an array ARR, int array, and int n, an integer n. If n is lesser than 50, insertion sort ARR. Else, we are telling the system to consider int mid is equal to n by 2, int array left is equal to arrays dot copy of range dot r the array 0 mid. The same thing we are doing for the right part after that, and after that the hybrid sorted version of the left array and the hybrid sorted version of the right array we are entering there. We are telling the system to implement the hybrid sort to the both right and left parts, and finally the merge algorithm, in the array to the left and right parts, both parts, hence the code gets implemented. Now let's go through applications of this concept in big data. It is used in pre-processing data for analytics pipelines. It is used for sorting logs for pattern recognition. It is used in Hadoop and Spark data shuffles. It is used in a core to search, indexing, and machine learning workflows. Now let's go through advantages and disadvantages of hybrid sorting. First of all, advantages. It combines efficiency and adaptability. It reduces time complexity in real-world scenarios. It improves cache usage and memory performance. It automatically adapts. It automatically adapts to input characteristics. But the disadvantages we have is implementation complexity. It needs tuning for threshold values. It not always is ideal for all data patterns. It is used as a debugging adaptive logic, which can be harder, very harder. Hence, these are the advantages and disadvantages of hybrid sorting. Now let's compare the performances of these sorting algorithms. For quicksort, time complexity is order of n log n, average case. Space complexity is order of log n. It is unstable. The suitability for big data is very high. For merge sort, time complexity is order of n log n. Space complexity is order of n. It is stable and it is highly suitable for big data. For insertion sort, time complexity is order of n square. Space complexity is order of 1. It is stable and lowly suitable for big data. And finally, hybrid sort, for example, tim sort or intro sort or whatever we have discussed before. Time complexity will be order of n log n. Space complexity will be moderate. It will be stable and it will be excellently suitable for big data. Now let's go through future enhancements. In future, parallel and distributed hybrid sorting can be implemented. Machine learning based hybrid selection can also be implemented. GPU accelerated sorting techniques can also be implemented, and adaptive thresholds using AI driven data profiling can also. Now finally, let me conclude this topic. Hence, hybrid sorting provides performance and stability for large scale systems. Java's timsort is a real-world hybrid algorithm success. It is essential in analytics, AI, and big data computation. It demonstrates the importance of combining algorithmic efficiency with adaptivity. Now let me give you the references for this topic. First, a book, Introduction to Algorithms, written by Corman, TH, and al. in 2009. A book, Oracle Java Documentation, written in 2024. And another book, Hadoop and Spark Developer Guides. And another book, The Art of Computer Programming, Volume 3, written by Nut DE. And finally, I would like to sincerely thank the respected professor for giving me this wonderful opportunity to speak on this wonderful topic. Thank you.